A very good afternoon to respected speakers, Mr. Vikas Dantale and Mr. Vikalp. And it is a very
This
great
is
moment for
Vaibhav
us.
Dantale. It's
Sorry,
not Vikas. This is Vaibhav, not
sorry.
Vikas.
I'm so sorry. Yes. I would, on that note, I would begin again. A very good afternoon to our respected speakers, Mr. Vaibhav Dantale and Mr. Vikalp. And it is a great day for us and a moment of proud to have experts from IBM India to help and guide our participants towards achieving more and more heights in research in this short term training program on leveraging artificial intelligence and data analytics for healthcare, sponsored by All India Council of Technical Education under AQIS 2019-20 and organized by Department of Information Technology from KJ Somaya Institute of Engineering and IT, Science, Mumbai. To introduce the speakers, Mr. Vaibhav, sir, is an expert in product development, cloud solutions, and data warehousing. He has 21 years of industry experience and is currently working as the executive IT architect, IBM India, located currently in Pune. Sir has a track record of leading solutions and delivery of complex folk cloud solutions like connected cars, SaaS platform for product optimization, and asset performance for mining industry, advanced IoT and data analytics solutions in ENU sector, and many more across various industries including telecom, healthcare, BFS, and insurance. Sir has been the lead of data modernization, offering development in cloud application services in the Client Innovation Center and infusion of exponential technologies like IoT, 5G Edge, blockchain, and cloud packs in building offerings. He has been engaged in senior leadership to create services point of view on various strategic initiatives at organization level. Sir has developed ecosystem for product database across ISA and MEA region through various strategic innovations, collaborations across business units and departments at leadership level as well as ISVs, business partners and SIs. Sir is a thought leader in IoT and analytics. He has delivered several presentations and conferences and events on complex solutions and pioneered various solutions in the space. He has built new assets from ideation through development and realization in real customer scenarios. Vaibhav sir holds 3 patents and 2 published discourses in the database space. Sir is also the co-author of 2 red books on data security and time series technology. And it is a great honor for me to introduce and welcome sir. And we are very fortunate to have you, sir. Welcome.
Thank you, madam. Thank you for a really nice introduction. Hope I'm clearly audible now, and
Yes.
everybody is able to see my screen.
Yes, sir.
Yeah,
Yes, sir.
yeah. So first of all, thanks a lot for giving this opportunity to talk to really such a big and great forum. Um, I know the topic of entire session, entire workshop is on from industry perspective, it's on healthcare, and from technology perspective, it's analytics. But then I thought proactively to propose hybrid cloud as a norm, but not an option, because that's what the trend that we are going to see, or in fact, we have started seeing in the market, right? And I thought I should bring in that industry perspective to educational field. Um, and that's why, I thought we should talk about this session. So we all know that, cloud has been there in the market for quite a long time now, right? And it definitely helps accelerate enterprises reinvent their way of working, their way of solving their business problem through IT and so on, right? So if you see on this picture on left side, when when the enterprises are following the traditional IT landscape like data center and typical waterfall model for executing the programs and the projects, you know, they 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 see very less agility, right? And Method is definitely one of the things that really hinders their agility, but then the platform or the landscape on which they are working also create a great hindrance towards agility, and that also hinder their progress in reinventing their business, right? And if you see on the left side on this slide, with traditional IT, where a project used to take 20 months, that can come down to up to 5 months with the cloud adoption and better practices of cloud native development, DevOps, and agile methodology of project execution. And enterprises can focus more on business value than dealing with the IT overhead, right? Typically 70% of their time they spent on IT operations overhead and create 30% of business value. With cloud coming in picture and DevOps, which is necessarily a lot of automation around project execution or various development life cycle, right? Um, and agile delivery of methodology, all three together can help organization to focus more on business values and optimize or reduce the IT operations overhead drastically. That's the value that really cloud is bringing on the table. And this is the industry point of view that I'm talking about, right? So with this, now we understand, cloud is playing really great role in helping business to reinvent. Next, we see there are various flavors of cloud, right? And based on the enterprises need, we adopt various models of cloud. Maybe infrastructure as service, platform as service, software as service, or application as service. And there is another one which is called as container as a service, which is almost equivalent to CAS and PaaS and IaaS, right? So this, you see the picture is in order of uh, how much customization or flexibility in managing infrastructure, and the amount of control that you get with moving from left to right. You you move towards more standardization or and lower degree of control on the underneath infrastructure, right? So there is no one fit for all. We cannot say that we should go only for SaaS, or we should go only for PaaS, or we should go only for infrastructure as service. It completely depends on what business problem we are trying to solve, or what application that we are trying to implement, and so on, right? So it's case to case basis, which eventually cause the mix of various cloud patterns in the overall IT landscape, right? So let us understand what are the um, various cloud definitions that we have. They are mainly defined in three categories. One is based on service model. What is the service model? Whether this cloud is about infrastructure as service, that as in it just provides the virtual machines or bare metal servers, and the cloud providers manages all that infrastructure, including VMs, bare metal server, network, firewall, and so on. Second is PaaS, that is platform as a service. So I'll just take you back to this picture so that you'll get more better understanding. So when we talk about PaaS, the the cloud service provider really takes care of the stack up to runtime, right? So they take care of network, storage, servers, virtualization, OS, middlewares like database or WebSphere or WebLogic and so on, and some other runtimes on top of it. And the enterprises are just supposed to bother about data and application on top of it. SaaS is something like SAP is offering you SaaS, or Salesforce is offering you SaaS. They take care of entire application, and enterprises just procure the instance of that software as a service, and do the configuration as per their enterprise need and start using it. So the cloud provider take care of entire stack up to application level. So these are the various flavors based on the service model that we see. Then there are various flavors of cloud based on the deployment model, whether it's a publicly available cloud, which means that it will have limited security uh, security measures implemented, and it is publicly available, or it is a dedicated, or it is private cloud. And third flavor is based on the service provider, who is providing the service, right? So which we all know that there are leaders in the market like AWS, Microsoft Azure, IBM Cloud, Google, and now Red Hat OpenShift is the container as a service, which is what IBM is proactively uh, promoting in the market. And there is a reason behind that. I'll touch base on that quickly, but not with the intention of marketing what IBM is doing, but with the intention of giving you better insights about what's happening in the industry, right? So definitely across these three flavors, there are certain differences, commonalities, which all together bring certain set of challenges while working on the cloud environment, right? So differences, you will see that the base infrastructure architecture may differ, cloud to cloud platform, or the services offering, or the technologies that they're offering, or the billing mechanism, or the service characteristics. So just to give certain examples, like services offering, when I talk about the event bus on AWS, the service is Kinesis. Whereas when you do that on IBM, it is Message Hub, right? Though both are based on the open source technology called Kafka, they have their own implementation of Kafka. They have added their own flavors on top of it, and they are offering as their own services, right? Technology and products used for implementation. So there are typical technologies, proprietary technologies that individual cloud providers are building. Like in IBM, you will see there are a lot of technologies in the analytics area, like Watson. Google has its own Google Analytics, and the implementations are completely different, may not be necessarily based on open source and so on, right? So they have different set of technologies as well. And then their way of costing, billing is different. This is one of the reasons that, for purpose fit applications or analytics purpose, enterprises are choosing the appropriate cloud platform, right? So if the enterprise really needs something like Watson with NLP and the knowledge catalog and so on, they prefer IBM. If they are looking something like a big data solution, they may go for Google or Azure, right? So it's all based on what exactly customer require. They choose the appropriate cloud platform, right? There are certain commonalities definitely across all these. Like most of them embrace the open source ecosystem and technology. All of them supports Kubernetes container platform, which is a very well known container platform, and have a typical set of services, like they have data AIML services or various tool sets for DevOps tool chain, and they do support polyglot technology approach for cloud native application development, like you must have heard, like serverless computing and so on, right? So with these differences and these commonalities, and as I said earlier, that based on the actual requirement, enterprises are choosing the appropriate cloud and ending up having various cloud platforms in their IT landscape, right? So you won't see any large enterprise having only one cloud platform. As per the survey, any large enterprise will have not less than 5 cloud platforms in their IT landscape, which actually brings in a lot of challenges, like having consistent use of common process and methods across tools becomes challenge. Their operating and delivery model, again, it's all about consistency, right? So, and at enterprise level, there will be set of security and regulatory requirement, and maintaining those across all cloud platform through single pane is another challenge, right? But nevertheless, that is the need of an hour now, right? Hybrid and multi-cloud platform. Um, because you will see that the industries are undergoing through unprecedented transformation. So the industries are really adopting cloud very fast, which means that they're modernizing their existing applications or the way they are doing analytics to really align to the way cloud works. For example, traditionally all of us, we have seen monolithic application, like one big application, which eventually will have certain scalability challenges, right? Which is getting now broken into microservices, and and is called as cloud native architecture now, and that really very well aligned to the cloud implementation and can leverage the cloud capabilities. In analytics space, we are very well aware of batch processing of fetching data, curating data, and so on, or AI ML batch jobs that we are aware of. That is also getting broken into small micro batches so that we can easily scale horizontally, because for vertical scaling, there will be always limitations, right? So these kind of unprecedented transformations that enterprises are going through, and few others, like to improve the customer experience, they are looking into social media data, or they're implementing internet of things. For example, in connected car, Maruti Suzuki implemented uh, connected car 4 years back to offer better safety or better user experience to their customers, right? Now when they implement such kind of things, they're hard to get humongous data, and managing that humongous data on data center is definitely not feasible economically as well as technically. So cloud, they definitely that they need to adopt. And now when they're selecting any IoT platform, they need to select the cloud platform which offers best IoT capabilities and so on, right? So we are seeing that there is a lot of turbulence happening in the industry, which is due to emerging technologies, mobile inception, or social media, churning data of social media, or Internet of Things implementation of blockchain, and so on, right? So which is actually forcing industry to adopt various cloud environments. There are other cases that we are seeing that the enterprises are using cloud for other various uh, use cases, like just to scale their existing environment. If they find that uh, the uh, the current data center is not sufficient, instead of expanding that data center, uh, they are putting all that overflowing stuff into cloud, so that, and definitely they choose public cloud for the things which does not need really high security and so on. That way they are optimizing cost as well as they're scaling, right? So there are various such use cases. So they're adopting SaaS platforms instead of installing entire software into their data center and taking overhead of managing it. Rather, they are adopting SaaS. As I had given example earlier, that they go for SAP SaaS or Salesforce SaaS, and they just subscribe for the instance of that SaaS application and use it. But then that SaaS application need to work with other enterprise applications. So there has to be integration between those SaaS cloud and the enterprise applications, which may be on a data center or public or private cloud and so on. Edge computing is another thing that you will see almost in almost in all industries. In manufacturing, you will see the data is being collected where the manufacturing machines on the shop floors are working. In healthcare also, there are a lot of electronic healthcare devices which are generating a lot of data. In certain cases, it won't be really efficient to bring all that data to the data center or on a cloud and then perform analysis. Instead of that, we can do quicker analysis then and there. For example, ECG, I can see the patterns and so on then and there near the machine and throw the results there itself. But then I need to get that data back into the data center to retrain my data models and so on. So we'll see such kind of various deployment patterns and adoption of various different types of clouds like private, public cloud, or data center, or SaaS, and so on, which eventually, brings a question in mind saying that, okay, fine, I need to, I cannot get rid of hybrid or multi-cloud. It's on my doorstep now, but then, what is the best approach to deal with this, right? So there are two approaches. One is hybrid monocloud or hybrid multi-cloud. So hybrid monocloud is you have your individual instances of your application on each cloud. Try to be as same as possible, but then you operate all of them differently. In hybrid multi-cloud environment, you can focus on consistent stack across all the cloud, so that managing entire stack becomes easy. Try to go for consistent architecture, right? That gives you, if you define the consistent IT landscape architecture, that gives you flexibility to choose the any vendor, right? So if, as I mentioned earlier, that based on your requirement, you may see that this particular application will be designed, developed, or executed well on maybe Azure, not on Google, but then other applications will work better on Google. Then I should have that flexibility, right? But that flexibility is bringing challenge. How to deal with that challenge is try to get the consistent stack across all the cloud environment, try to follow the open standard based softwares and so on, right? So so basically these are the two patterns that we just discussed, that you go for separate environment with traditional operation model, or you go for single hybrid cloud platform and operating model. So with separate environment, where we'll be having separate environments, they will be having their own operating model, ticketing system, configuration system, security compliance systems, and so on, right? Versus in hybrid cloud environment, which is like a single pane that you can create, you can follow single abstract hybrid fabric, and manage consistency across all the cloud platform, so that you can follow same configuration, same process. You can create a single pane of glass to manage the entire multi-cloud environment, right? And you can follow, it will be easy for managing the compliance, security, and so on. As well as from workforce perspective, it is having the single hybrid cloud platform. You can reutilize skill across the various applications or various streams with which is what will be challenging with separate environments, right? So the answer to the problem that we have been discussing is go for single hybrid platform and operating model. So as per the survey that IBM had done a couple of years back, we are seeing that the maximum enterprises will have combination of traditional IT, which is what we call as data centers, and private cloud, public cloud, dedicated cloud from deployment perspective, and then various service providers into their IT landscape. So they will have not less than 5 cloud environments, right? So now what does that mean is, if I take a simple example of analytics, right? So we all know that if we want to perform any analytics, uh, we need to collect the data from various sources, curate it, and then run models on top of it, right? So collecting data from various sources, when we say, unlike the previous way of working, that now the various sources on different cloud, they follow different security norms, they follow different integration norms, or they follow different services, they use different technologies, but we need to collect data from all those and get it into the analytics space, right? So these kind of things, we will see that will be evolving more and more, and hybrid integration is going to be another focus area due to adoption of hybrid cloud environment going forward, right? So there are five principles which defines the approach to really handle this multi-cloud or hybrid cloud challenges. One is, we should look at enabling enterprises to work across public, private, and traditional environments. So there are certain guidelines to really understand when to use public, when to use private, when to use traditional environment. How do we create a single pane across all these cloud uh, deployments? Similarly, on multi-cloud, there has to be a single pane of glass to manage all the clouds, so that for a user it has to be really transparent that on which cloud he or she is really monitoring or really dealing with, right? Follow the open standard as much as possible, so that it gives you flexibility to move your workloads across various cloud environments and avoid or reduce the vendor lock-in. Security, this is very important topic. Anyway, Vikalp is going to cover it after this. So while adopting this hybrid cloud environment, there has to be really a proper security governance needs to be implemented across all the cloud environment to ensure that there is no loophole left, and the security implemented in a way that it is really complying to industry standards or enterprise requirements, or geography compliance requirements or regulations, right? And manage is really, which talks about logging, tracing, monitoring, ticketing, and so on, right? Or deploying the new workloads and so on. So there has to be a single pane for managing all these things, to deal with that hybrid cloud environment challenges. This is just I thought of showing you understanding all these problems, what is IBM's high level cloud portfolio is. So this is very typical layered architecture, enterprise architecture, or we call it as a cognitive architecture, um, wherein you see at the bottom there are various cloud uh, platforms, and then there will be a foundation on top of it. We know that most of us, we know that Linux is the most preferred operating system across all the cloud environments. But then containers are picking up like anything now, because they offer flexibility, they offer portability across cloud environment, and that also helps us to create the consistent architecture across all the cloud environment. The moment you have consistent architecture across all the cloud environment, the the management overheads, or operations management, change management, all those overheads reduces drastically. And that's why the container as a service is picking up like anything, and is playing really vital role in adoption of hybrid and multi-cloud environment. And then above that foundation, there will be various capabilities around application, data integration, management, automation, and security. And then there are various advanced technologies, or we call them as emerging technologies, which are like artificial intelligence, analytics, blockchain, encryption, and so on, right? So just to give you example of distributed analytics, right, in the hybrid environment. We spoke about various flavors of hybrid environment based on the deployment patterns, or based on the cloud provider, or based on the service that we choose, right? This is a little bit different example, and which actually also talks about the age, right? So last year, IBM IBM introduced two key capabilities. One is IBM Edge Computing and IBM Cloud Bank for Data, right? So I'll just talk a little bit about it, just to give you some industry perspective. So Cloud Pack for Data is completely based on the container platform, and um, I'm not sure whether how many of you know that IBM acquired, partnered with, as well as later on acquired the Red Hat OpenShift platform, OpenShift container platform, a year back, right? Uh, with the vision that the enterprises, every enterprise is going to have the hybrid cloud environment, and OpenShift is going to be the best answer for that, right? And then second thing IBM did is develop the entire cloud pack for data on OpenShift. Now, what this cloud pack for data is, it's actually the set of various IBM and some open source technologies combined together or bundled together with pre-integration, which are required for the typical large-scale analytics platform. For example, for analytics platform, it starts with collecting the data from various sources, which needs either ETL or fast streaming data. So at collect layer, there are two products like ETL and something called as InfoSphere streams. Then once we collect the data, we store the data into the database or in storage, and there are various storages required based on your data volume or data velocity, or how do you process that data, or how do you proceed that data further, right? So there are various database technologies or data storage technologies bundled, like MongoDB, PostgreSQL, DB2. So these are NoSQL and SQL flavors. Cloudant is another NoSQL flavor, and big data as well, right? Then once we store the data, we need to perform analysis of that data. So there are various data curation and data analytics capabilities. Those are part of our Watson suite of products. Those are also bundled into the Cloud Pack for Data. I wish I could have bring the picture of it. That would have been easier to explain. Sorry about that, I didn't bring that. And then there is visualization of that data, right? So there are various visualization tools that IBM has, like Cognos, right? So, and then security capabilities like Guardium and so on. All those are bundled in this Cloud Pack for Data. So you get whole gamut, whatever you need for performing analytics. Then there are certain really um, really innovative solutions that or innovative product that Cloud Pack for Data has. One is the data model monitoring tool, which continuously monitors how the data model is, the AI model is performing, right? And it just checks whether it is deviating from from the uh, the results that it is expected to give. And if it does, it generates alarm. And second part of that is when it generates alarm, it tells that the data model needs to be retrained. So it also, there is another part of the tool which tells that which data set we really should use to retrain the data model. So a lot of artificial intelligence within artificial intelligence tools is brought in here. So that's about the cloud pack. Now, typically, we will see that in IoT solutions or IT solutions where we are collecting the data, bringing that onto the cloud, and we're performing analysis, right? Now that trend is changing uh, because when you bring the data all the way from the device to the cloud and then perform analytics and revert back with analytics, uh, there is a lot of latency. In certain cases, that does not work. Uh, I know manufacturing very well. So in manufacturing, if you're performing some job through machine, if there is some deviation in one or two of the parameters of that particular machine, that literally um, deteriorate the quality of upcoming uh, product, right? So it needs to be immediately intimated. Latency of, in certain cases, even a 1 minute is not affordable. I know, I'm sure there will be a lot of such situations in healthcare as well, because it needs to deal with lives of people, right? So, there will be definitely a lot of use cases for edge um, in healthcare as well. So what does it do is, on edge, we can deploy programs, and which will collect the data, which will literally perform analytics. So it can do pattern matching, anomaly detection at edge, at least, which does not need really humongous data, right? That kind of detection can be done at edge, and the prepared data can be sent to the cloud via some server on premises, right? That kind of environment we'll see in certain scenarios. Now, if you see that uh, we will not have one edge device, right? So it will be in numbers. It may be in hundreds of edge devices, right? So we need to see that my deployment of application or the overall execution environment or workload environment has to be consistent across all these 100 edge devices, right? And then that needs to be consistent with my on-premises data server, and that needs to be consistent with my cloud environment as well, so that the streaming of data or the integration of all these three entities will be really seamless, and any change management across this entire landscape will be easier, right? And that's what actually the IBM cloud satellite and IBM cloud edge capabilities plus cloud pack for data together all together brings, right? So this is one different type of example I thought I'll share with all of you on this hybrid cloud. Okay, so this is also treated as hybrid cloud because edge is a different type of deployment. On premises, you will have data center kind of environment, and on cloud, you will have different kind of deployment. You will have different kind of uh, services there and so on, right? So with this, what we have seen is that most of the organizations really achieved the have already started the journey towards adoption of cloud, and slowly they are getting into this hybrid and multi-cloud environment. But still, there is a lot of journey yet to be covered, right? But the target definitely is going to be the single hybrid, integrated hybrid platform going forward. And if the enterprises don't adopt if they adopt single integrated platform, they will be almost 2.5 times more efficient, can generate 2.5 times more value. So we do have, IBM has done some research on this, have some calculations behind it. It's not hypothetical number, definitely, right? And they can be 2.5 times more efficient than just following a single platform or single cloud strategy, right? So with this, so I think I'm able to convey the message that, that the new normal is hybrid, multi-cloud, and open, and no more a single cloud strategy. Right. So with this, I would like to conclude my presentation and would be happy to hear any questions if you have.
Thank you so much, sir, for your wonderful session. The forum is open for participants to ask any questions related to cloud and even its concern with healthcare. Anyone from the participants?
Hello, good afternoon, sir. This is Prashant here.
Yes.
Sir, what will be the role of cloud technology whenever we are talking about healthcare industry? Like nowadays, if you talk about CT scan image and other digital source, so how we can use this source and we can upload it on, or we can say that when you use the cloud technology, so what kind of what we can say, I mean to say, service we have to use for that?
Yeah. So see, basically, in healthcare, typically we'll be doing a lot of image processing, right? We'll be
Yeah.
doing a lot of IoT data operations, right? And there will be uh, a lot of predictions that we'll be doing, right? All these, if you see, are actually trending towards generating humongous data and churning out the humongous data. Plus, it will need all specialized AI capabilities to really understand the data, right? For example, when I'm talking about image in medical or healthcare field, it's not something like face recognition only we are talking about, but there's a science along with that, right? So, for example, I'm processing image of X-ray, I'm processing image of sonography, maybe, right? So there will be a lot of interpretation of that information will be required, right? So, so first part is managing this humongous data, right? So there are various services that clouds offer to collect the data and store that data efficiently on cloud. For example, when I say efficiently, one is economically cheaper, second, secure, and in optimal way, right? So when I say economically cheaper, we all know that when we want to store anything in computer, there are various storages, like you will have SSD or HDD, but they are really costly storages. On cloud, there is something called as S3 or Swift or Object Store, which is way cheaper, right? So I would say it's almost 1/10 or 1/28 of cost of our normal SSDs, and or even cheaper, right? So that is one thing it will have. Then you will need combination of various technologies together to really generate some meaningful information out of the data generated uh, in this healthcare, right? So like we need to use IoT to collect the data. We'll need various type of database technologies to store the data, manage the metadata, and then we'll need various technologies to really process this data, and humongous infrastructure will need, right? In fact, in certain cases, a normal CPU will not be helpful. You will need GPUs, right? So procuring GPUs and spending capex on it is really not advisable. So cloud can help you optimize that cost entirely by offering you GPU on cloud so that you can process the data in cheaper way, right? And then coming to various technologies, as I said, IoT is there. And if I take example of Watson has a better way of managing catalog of data, or has various pre-built AI models as well, and so on. So we can use various technologies, combination of technologies on cloud, and you can provision it whenever you want, and you can just decommission it once you are done, which you cannot do that on data center, but you can do that on cloud, right? So and you will have a whole gamut of all the technologies available to provision in a click on cloud, which you cannot do that on data center. So that is how this cloud will help, uh, not only in healthcare, but in almost all industries.
Thank
It
you,
was
sir.
long answer, but did that answer your question, sir?
Yes, sir.
Okay.
Okay, great. Anyone else? Okay, fine. Thank you so much, Vaibhav sir. It was an excellent session, and this is a dimension every researcher should be aware of. And thank you for adding the feather to the cap we're preparing under this STTP. Thank you so much,
Yeah,
sir.
sure. Thank you.
So, dear participants, moving on to the next part of our session, and I'm very fortunate to introduce to you the speaker for our afternoon session, part 2, Mr. Vikalp Nagori. Sir is a senior managing consultant, security strategy, risk and compliance at IBM and is currently located at Bangalore. Vikalp sir is an information security expert with 19 years of experience in security risk management. He has managed several security risks from CISO office of large multinational banks and enterprises for around 10 years. Mr. Vikalp has executed security advisory and project deliveries from technology and consulting firms. Vikalp sir's expertise and focus areas include multi or hybrid cloud security and workload protection. His experience in risk management spreads across compute, network, application security, and managing 24/7 security operations. He is expert in drafting enterprise security policies, standards, and reference architectures. He has delivered projects on PCI and HIPAA compliance and managed SOX ITGC for large enterprises. Vikalp sir has several certifications like CISSP, CISA, CSSLP, PCIP, PMP, AWS Cloud Practitioner, etc., and several badges of IBM on Docker, Kubernetes, Blockchain Essentials, and many more. Currently at IBM, sir is leading a team of 20 plus ethical hackers. He has transitioned DevOps to DevSecOps, if I'm pronouncing it right, sir, and
Yes,
consulting
absolutely.
for yes, thank you, sir, and consulting for security transformation with Shift Left and DevSecOps. Sir has been a former vice president and information security officer for CITI City, Singapore, wherein he was governing information security risks for 1200 plus consumer bank applications. Sir has also been a lead consultant at Wipro Technologies Bangalore in the past. Previously, he has also served as a chief security officer at Societe Generale, Bangalore. Sir has also worked as a senior consultant for Infosys Bangalore, as well as consultant information security at Vincity Networks Private Limited, Bangalore. With so many work experience in diverse areas and such great knowledge, we are very fortunate to welcome Sir for the session. Thank you so much, sir, for accepting our invitation and agreeing to deliver the session in benefit of the participants. And we are all ears to listen about privacy security concerns because that is something at the heart of healthcare. And when we talk about launching so many applications and doing so many stuff using AI, ML, and data analytics on healthcare, which is the most sensitive data that is being underlined and work upon, we are very much desperate to listen to you, sir. The virtual floors is all yours, sir. Thank you so much.
Thank you, Dr. Radhika, for introducing me. Thanks, Sri Prashant. And thanks to my colleague Vaibhav for introducing me to Department of. Good afternoon to all of you. It's my pleasure talking to you today on data analytics for healthcare. Let me share my presentation. All right, so today we will talk about current trends and challenges health pandemic last year and it's still continuing, and unprecedented
Vikalp,
attacks on the research.
Vikalp, you're breaking in bit, not breaking, but we are losing you in between for a second or two.
Okay, let me try. All right, so we will talk about current trends and challenges healthcare industry is facing. We faced last year, still continuing, and unprecedented attacks we had on the research. We will
So
also talk
sorry
about
to interrupt you, sir. Still, there is the breakage in between.
connection. Just a minute.
Yes, sir.
All right, I have changed my internet connection, and I hope it will be better.
Yes, sir. It is better, sir.
All right, thank you. All right, so we'll talk about trends and challenges, and then we'll get into homomorphic encryption and talk about how FHE helps in reducing the constraints for doing analytics in healthcare. And then we'll talk about cloud security. It's a joint responsibility, and that's kind of a good hygiene and safety instructions. All right, so we all know the importance of data in healthcare, and not just healthcare, but in every industry. Data is in fabric of our lives more than ever, and it will continue to solve problems and improve our lives. Data analytics in healthcare has immense opportunities to transform healthcare from reactive to proactive, provide quality healthcare, quality diagnosis, and treatment across the world at affordable cost. Digitization in every industry is growing, including healthcare. And we have observed with the pandemic, the speed of digitization has increased. And that's a positive side of pandemic we see. And it is because of the pandemic that we are all connected virtually today using a cloud-based platform. Um, Digitization of healthcare with integrated analytics will be critical for advancements in healthcare. Now, healthcare is an industry that generates massive data. Now, with digitization of health records, sensors generating data, trackers for preventive health and fitness generates data. So with so much of data and evolution of 5G and edge networking, we will see more and more data available for analytics. And that will fuel further advancements in healthcare. So it sounds all good. So what is the challenge? So as we have more and more data generated and available for analytics, there are increased concerns from security and privacy. And these are reasonable concerns as it has an impact to humans and society. So now look at some of the trends we had on security and privacy from last year. And when we say last year, it's 2020, I mean, just a week back. So we saw unprecedented cyber attacks on healthcare. It was almost 40% higher than what we saw in 2019. So the healthcare industry was stressed more than ever due to pandemic. And so were the cyber criminals targeting healthcare industry for ransomware attacks to turn it into inoperable state and cyber criminals trying to increase their rate of ransom collection. And these attacks were financially motivated and targeting healthcare IT. We also see other pattern of attacks, and that was not motivated for immediate financial gains, but to steal data, research, um, and this research was related to a vaccine, I mean, generally for last year. But otherwise also there are nation state actors target for research, and their objective is to obtain supremacy over other countries. Cyber attacks took aim at hospitals, public health authorities, from local governments to WHO. And as healthcare industry was racing ahead to develop a vaccine, security researchers detected nation state actors targeting prominent companies involved in researching vaccines and treatment for COVID. Attackers were also behind vaccine supply chain. Several countries were targeted, including India, for vaccine-related research and trials. We also saw unprecedented attack late last year, we are talking about last month or two, where nation state actors were attacking by embedding malware in a network management software. Thereby, they were leveraging IT supply chain for stealth attacks, stealing data, and spying. So what do we infer from these trends? So we spoke about on a very general basis, two types of actors here. Actor one, who is financially motivated and their objective is to make financial gains immediately. And those actors are typically trying to work with the ransomwares. And there is another set of actor who is busy in stealing data, research, intellectual property, secrets, and their objective is not immediately monetizing their work, but to attain supremacy, and later they get larger gains than what a ransomware criminal can get. And for these threats, healthcare data is very sensitive. The unauthorized disclosures of data not only impact research, but also impact individuals involved in trials and so on. There's another fact here in terms of shelf life of stolen data. So healthcare data has a longer shelf life than financial data. So in financial industry, banks and card issuers can quickly replace cards, change numbers based on a suspicion of attack or incident. But in healthcare, condition of a patient doesn't change as fast as card numbers in financial industry. So this increased shelf life of stolen data is also another reason cyber criminals are increasing their focus on healthcare industry. So that's what we see in terms of security. Now let's look at what's happening in regulations. There has been a lot of regulation already, and number of regulations still coming up. So in US, there is a law such as HIPAA that's applicable to healthcare and insurance industry. There are other industries that are regulated by FDA. And depending on the nature of business, there's so many other industry-based regulators. They're government-based regulators. Europe got its much broader privacy law with GDPR. And now we see in US at state level, several states are coming up with their own privacy laws to protect individuals' privacy. With these laws, the penalties are stringent and there is increased awareness on the privacy and right to privacy among society. So that adds another challenge in collecting sensitive data, patients' data, and putting it through analytics and machine learning. So we have two challenges. One is the nation state actors who are behind such data to steal. And second, the regulatory concern, compliant related concern, and regulators make it very difficult to put this data through certain algorithms, and especially if this data has to be moved into cloud um, for advanced analytics. Now, technology is advancing. So earlier we had a bit of a gap. I mean, the laws and regulation doesn't work in the same pace as technology. So we used to have technology companies manufacturing smartwatches, fitness trackers, bands, fitness apps, and collecting a lot of biometric, personal, fitness, and health related data. And by definition, the technology companies or app providers were not directly under the ambit of a healthcare company or healthcare entity. So they were kind of outside, right from the perspective of a healthcare provider. But now, though behind, but laws are catching up with a Smartwatch Data Act that brings even the technology companies under the ambit of HIPAA. So these challenges will continue. So we need to see, how do we address these challenges? Now, as we mentioned earlier, that analytics of healthcare data is very important, and it is required for kind of a converting from a reactive to proactive healthcare, researching, and I mean, it was, I'm sure, very helpful in treatment of COVID and developing vaccine for COVID. And those are some of the use cases. So typically, I mean, we look at traditionally when we do data analytics, during computation, the data is required to be decrypted. So though data is encrypted in transmission and storage, but for computation, the data gets in clear. And the result of computation is also in clear. Now, imagine healthcare provider, healthcare industry and hospitals and researchers want to partner with a technology company who specializes in AI and machine learning for advanced analytics. They wouldn't like, or there will be apprehensions on sharing this data with the technology company, or um, sharing this data in cloud for advanced computation, just because there's a concern that for a moment, or when the data is computed, data isn't clear. And that kind of hinders or puts a constraint in advanced analytics in healthcare. So let me talk about fully homomorphic encryption. This is a breakthrough from IBM research, and FHE we call it. It was just released last year, mid of last year, after 10 years of research. So right now, FHE is in pilot. IBM has done a few pilots with a few of the banks, and the results are very good, and the success rate is high. So still, this technology is in pilot, where we work with our clients in different industries to do this pilot and bring the technology for analytics. So how does FHE helps? Uh, it helps in computing on encrypted data, and the result is also encrypted. We'll talk about its use case in a while, but uh, let's look at what it is. So what if we could begin to unlock the value of sensitive data without decrypting it to preserve individuals' privacy? I mean, that's the question we are trying to answer. IBM Research developed fully homomorphic encryption, which keeps sensitive data encrypted at all times and securing the cloud for highly regulated industries. I mentioned cloud here because FHE requires a lot of compute power, and which we do not expect a healthcare entity would have in their own data center. So it would be typically required to leverage a cloud with a large compute capability. So FHE allows for encrypted data to be computed upon within any domain. When we say any domain, it could be in the healthcare's domain or third-party domain or in a public cloud, going beyond data encryption at rest and in transit. So FHE provides a way for universal freedom of information to exist with individuals' right to privacy. Now, healthcare industry can reap benefits of partnering with a technology company that specializes in AI and machine learning for data storage and computation. And this can be done even in public clouds without worrying about compromising privacy and security. So this is invented by IBM Research, and it's the first and only known technology which is right now available in pilot. So when I say first, there are other technology companies also researching on FHE. That's a Microsoft, Intel, and I also heard of a university in South Korea researching on fully homomorphic encryption. But IBM has taken a lead here, and it's already in pilot. Well, this forum is not to market IBM here, but we're talking about how do we solve the constraints in analytics in healthcare. And just that IBM is ahead of it, we're talking about fully homomorphic encryption as one of the potential solutions. So this is not just encryption at rest or in transit, but rather being operated on by the CPU and and remaining entirely encrypted in memory, in storage, and in flight. So how does it work? So in step 1, the owner of the data encrypts plain text into ciphertext, which so basically plain text is converted into ciphertext. And step 2, this data is put through analytics. So computations are performed directly on ciphertext. And step 3, the encrypted results are then sent back to the data owner. So that way data and the results can only be decrypted by the data owner, and security is not compromised in computing and analytics. So we are kind of assuming that computation and analytics is happening outside the domain of data owner. So that's where we are talking about encrypted data is given to or given for computation and analytics. But it's from a concept perspective, the use case of this technology is to take encrypted data and then perform computation on it and then provide the encrypted data and the results back to the data owner. So how does FHE helps? It helps in analytics over FHE data, basically encrypted data. It helps in encrypted search and data matching. It helps in encrypted artificial intelligence and machine learning, so we can put the encrypted data to ML algorithms, and encrypted biometrics and behavior. Let me also play a short video here. I think that will help. It's just a three or 4 minutes of a video.
Our private information and data are being shared more widely than ever before. And often, we're the ones sharing it. We share our data in exchange for convenience and improved services. As long as our personal accounts remain untouched, we think nothing of it. And for most, giving up our personal information is required to interact in the digital world, both at work and to utilize basic everyday services. So how do we know our data is safe? Well, most of the sensitive data we share is encrypted. Encrypted data is useless to hackers and thieves, as it's translated into complex code or ciphertext that can't be read by humans. That's a good thing. But while encryption safeguards our data as it's being stored or transferred, the data must be decrypted or translated back into clear text to be processed. This provides a window of opportunity where your data is exposed, making it vulnerable to cyber criminals, privacy violations, and other misuse. IBM is combating this problem with fully homomorphic encryption, or FHE, which is changing the paradigm of security. It's a technique that enables computers to process sensitive data while it's still encrypted. For example, every time you hop in the car and fire up your phone's navigation app, the app needs to know where you are, where you're going, and any stops along the way in order to give you the best route. With FHE, the app could still provide those same directions, without the service behind it needing to see or save that information about you. Maybe you don't care about an app knowing your location. Maybe the convenience outweighs the risks. But what if this data was much more sensitive? Like, say, healthcare records or your personal banking data. Suddenly the stakes are much higher. The ability to apply AI, machine learning, and other computing functions to data without exposing more private information is the essence of what fully homomorphic encryption enables. First envisioned in the 1970s, an IBM researcher pioneered the mathematical framework to make FHE possible in 2009. But FHE was too slow for everyday usage because of the enormous computing power it required. Back in 2011, it took 30 minutes to process a single bit using FHE. But by 2015, we could compare 2 human genomes with FHE in less than an hour. And now through software and hardware advances, the time has come for companies to start experimenting with FHE. FHE will be a game changer for security in the hybrid cloud era, unlocking new business opportunities. With its ability to process regulated and sensitive data, FHE will drive wider enterprise adoption of hybrid cloud platforms, especially in highly regulated industries like financial services and healthcare. FHE could also impact mergers and acquisitions, where due diligence could be performed without violating the privacy of account holders, shareholders, and clients. Even airlines, hotels, and restaurants could utilize FHE to offer packages and promotions without giving their partners access to details of closely held customer datasets. But first things first, companies need to get their hands on this technology to begin developing real-world usages for FHE within their unique industries. With the launch of IBM Security's homomorphic encryption services, clients will gain access to both the tools and cryptography expertise needed to start building prototypes for their own FHE-enabled applications. Pushing forward on this new frontier of security is part of what positions IBM as the leader in hybrid cloud, all the while protecting the privacy and trust of clients and keeping your data safe.
All right. So I hope you could hear the voice on the video as well. So everything sounds so good. So the question is now, what is the challenge? Is this technology as simple as downloading tools and libraries and using it? So there are current challenges in implementing FHAs. And these are like the developers need to be trained on the concept of FHA. They need to understand the design considerations and constraints in building solutions. The developers and data stewards need to prepare data requirements and leverage tools and libraries and services for hosting FHE-enabled workloads. The other challenge is compute on FHE encrypted data is intensive. So it takes 10 to 100 times more compute power than normal computation. And it's a challenge for a healthcare provider to kind of perform all these or address these constraints on their own and their own data center. So that's where healthcare providers would need a technology partner to provide them a large compute capability, and it's going to be typically in a cloud, and provide the expertise for training developers and data stewards in terms of designing the data, uh, building the concepts, and addressing the constraints while building solutions. So from IBM perspective, I mean, it's in a pilot, so it's not just we are releasing libraries and tools, but it comes with our own cryptography experts coming as consultants and working with developers who are working on applications enabled with homomorphic encryption for analytics and big data. So it's a service plus technology right now. And it was released last year, and we are doing several pilots right now with several of our clients. All right, so let's look at one of the case study. I mean, I think we have just mentioned about analytics is one of the primary case study here, but from a hospital perspective, a typical hospital's data center cannot match the scalability and efficiency of a cloud or a technology service provider's compute power, particularly in hosting workloads for large clinical trials for complex genetic diseases. I mean, hospitals are focusing typically on their own core expertise, and they would like to partner with some technology company who could provide the capabilities for hosting workload and computing on it. But the moment we say, okay, partner with a technology company and provide them a complex genetic data or clinical trials data, there is a privacy risk, there is a security risk, there are a lot of regulations overhead that kind of challenges the whole thought process of giving this sensitive data to a technology company for performing these tasks. So FHE helps in clinical research that can improve the acceptance of data sharing protocols. And of course, when data sharing protocols are accepted, it helps in increasing the sample sizes and accelerate overall learning from real world data. So that helps in advancement of healthcare from just a reactive to proactive and doing a lot of research. All right, so let me pause here and kind of reflect what I spoke for last 20, 25 minutes or so. So we spoke about security and privacy related challenges in healthcare, especially what we saw last year in terms of attacks from cyber criminals and nation state actors. Their objectives were different. Some were behind money and some were behind research, and especially some attacks were targeted for vaccine related research. We had an overview of FHE as a technology and what it does and why we are bringing here because of its capability to perform compute and analytics on encrypted data. Now, let me mention here that FHE is not a silver bullet that's going to solve all the challenges from security threats. So when I say security threats, we had two different types of actors. One actor was targeting primarily with the ransomware kind of attacks. There were other attacks as well, but prominently we see ransomware attacks where that's where they can monetize their efforts. So the objective is to make IT infrastructure of healthcare provider or hospital inoperable so that they can collect ransomware. And FHE is not a solution for that kind of a threat, right? So it's a different class of a threat wherein somebody is attacking healthcare IT. Now, securing healthcare IT requires a holistic information security program. So healthcare providers are already working on their information security uh, controls, overall organization, governance, audits, and so on. So in this session, we have not talked about such information security programs here. We haven't referred the top 20 controls required or top 30 controls required to protect the healthcare IT. And we haven't touched upon the security frameworks, maybe from say NIST or other institutions. So all this was required, still required, and will continue to be required. I mean, we have not touched upon healthcare IT security. That continues its focus, and it's required to be in focus because of increased cyber attacks. We have introduced FHE here for not that purpose. So FHE is introduced for the purpose of the second class of actors, or I would say threat agents, who are behind research, who are behind clinical trials, who are behind the sensitive data. They want to steal it and they want to kind of bring in supremacy. One country is trying to gain power over another country. So in these kind of a scenario, or there is a cyber espionage. So pharmaceutical company from a country is trying to target another country's pharmaceutical company and trying to steal research and trying to go ahead with their own research and development of vaccine and medicines and some treatment. So for those kind of scenario, wherein people are behind data and there are apprehensions in terms of using healthcare data for analytics analytics and putting this data through machine learning. For that kind of a use case, we are projecting FHE as a technology which can be a game changer, which can help in getting acceptance on data sharing protocols, which helps in gaining approval from regulatory authorities for giving this data to a technology company who masters or specializes in artificial intelligence and machine learning. So just to kind of coming on a conclusion here before we jump into another topic is that so we don't want to portray that FHE is a silver bullet will kind of solve the healthcare IT's problem. It is only for a specific use case of encrypting it data and then putting the data through analytics so that the privacy of individuals and the secrecy of research can be preserved. So that's the use case here. All right. As I mentioned at the beginning, that we'll talk about safety instructions. So these are, I mean, maybe you would have heard it sometime, or maybe multiple times, but I call it a safety instructions. It is as good as like we travel by airline, and every time we onboard a plane, we hear safety instructions. So in spite of you heard it earlier, just because we see some misnomers in industry and misunderstanding in people, we wanted to cover two areas here from the perspective of cloud security. So there's a misnomer or misunderstanding that cloud is secure. So the applications and data hosted in cloud is also secure. So the point I want to highlight here is just because the cloud is secure, your application you develop or data you host doesn't get secured automatically, right? So well, cloud service providers have done a great job in building secure clouds and putting it through lots of attestation, certification, audits, testing, so that they can convince people that cloud is secure, and they have done meticulous job in doing that. But that understanding shouldn't give or shouldn't lead to a conclusion that since cloud is secure, so whatever we host on the cloud is automatically secure. So there is a shared responsibility between cloud service provider and consumer of cloud services. So similar pattern you've seen in Vaibhav's presentation. So the objective was a little different. Here you see in a diagram different patterns of or services provided by cloud. So this is very simplistic view, but in real life, it's not as simple as this. But what we are trying to highlight here is the responsibility for security is shared between consumer and cloud service provider. And the scope of responsibility changes based on the consumption pattern. So in a software as a service, so for example, we use a Gmail or here right now we are using Microsoft Team. These are all software as a service. So it's very little we have to configure for security. But then as we go towards infrastructure level utilization of a cloud-based services, it requires much more uh, diligence on security at the consumers end. So, so we just wanted to kind of a clarity here that there's a shared responsibility. So just don't assume that cloud is secure and just start using it without worrying about your own responsibility for securing application and data. There's another misunderstanding or misnomer we see among people, and that's a thinking that once we deploy our workload, our application, and configure it securely, and imagine that we have configured it securely, we also had an audit and we have tested it and everything goes well, and then we forget about security. So that's a problem. Um, you can't forget about security after once a configuration. So security is not a one-time job. It requires a continuous compliance and continuous security of the data and application. So if assuming that that's the only responsibility of a consumer. Now, if you look at some examples, we had lot of incidents because of accidental data disclosure, and all that happened through Amazon S3. So what happens? People upload their data on S3 bucket. S3 is a great service from AWS with a lot of security underneath it, and also a lot of security features available for consumers to configure and turn on. But what happens if at the initial stage, it may be all configured right, but over a period of time, our configuration changes, application changes, we make a lot of changes here and there, and over a period of time, those security configuration changes. And generally, when in cloud, people are using the graphical user interface. It is very easy to configure security features with a radio button and drop down. At the same time, it is also easy to misconfigure it, or with the changing responsibility of a people in an enterprise, that misconfiguration happens, and that exposes the data in S3 bucket. So that there's several of incidents where millions of records of data have been exposed accidentally. So nobody had to kind of hack in or put in a kind of an effort. It was just available over internet because of a misconfiguration. So it's a very simplistic example I have given. But when we say continuous compliance, what it means is having visibility of the assets. So as Vaibhav explained that, we are going to have hybrid cloud, we may have multi-cloud, and he also spoke about 5 different types of clouds. So that's a different scenario from a typical enterprise IT, where everything was in a single data center and we have uh, a single way of managing inventory. But now what is required is to have a visibility of assets deployed across multiple clouds or hybrid cloud, and having a view of continuous compliance or security status or posture on the configurations and on the assets, and have policy deployed such as we can automatically remediate based on any deviation from the security baseline configured, or generate alerts, and based on alerts go ahead and remediate if there's any exposures. So these are the two topics which we see generally are having problem in industry. We wanted to kind of touch upon here just for benefit. You might have heard this, but take it like a airline safety instruction, and it was a repeat. So all right, so that's all I had to cover today in terms of constraints, security and privacy related constraints in healthcare data analytics. So yes, there are constraints, but technology is evolving, and we have solution available in pilot, and not just IBM, but other technology company are also working on FHE. So solution is there to reduce the constraint, and we can kind of work all together for betterment of healthcare sector and improvement in human lives. That's all from me. Feel free to ask questions, or feel free to send me email for any questions later on.
Thank you so much, Vikalp sir. It was a great session, and I personally have been working in privacy preservation and with encryptions, especially homomorphic encryption. So this was something a real touch required when we talk about healthcare and applying artificial intelligence and looking at the privacy and security perspectives. Thank you so much for your session. And in case the participants have any question, we are in time to address them. Okay, so I see there is as such no question we have from the participants. So on that note, thank you so much, Vaibhav sir and Vikalp sir, for spending your so much valuable time. Coming it from an industrialist is altogether a different view to have, because all who have been addressing this STTP, or who have been attending this STPDP, mainly belong to academia. And industry academia connect can only strengthen the research that India is carrying out. So thank you so much for spending your valuable time. I thank Professor Prashant for making me connect to you, and for us to have the two of you deliver the session in benefit of the participants. Thank you so much, sir. We had a
Thank you
great
very
time.
much. Thank you
Thank
And
you
we
everybody
look
for
for
forward to
inviting.
sparing
further
your time to
collaborations with you.
this.
And whenever
Yep.
you visit Mumbai, we want you to see us in our campus.
Certainly, it will be our pleasure, ma'am. Thank you.
Thank you, sir. Thank you. Thank you.
Sure.
Thank you. And thank you to the participants for being present with complete attention and time. And tomorrow we'll be having the final day of the STTP. The morning session start at sharp 9:45. Please be there on time. And in the afternoon, we'll be having one session from 1:30 to 3, followed by the exam at 4 p.m., 3:30 p.m. So 3:30 to 4:30, we have an exam. Anyone who has any issues with concerning exam supervisions can please write an email to Mrs. Sarita Rathod with CC to me. We'll be able to address that as well. So see you tomorrow, and thank you so much. Ensure that you are well prepared for the exam, because 60% is the minimum passing criteria. Thank you. We are having a good time to serve you. Bye-bye.